All right, welcome to section 17.3. And I put the course goals from the online book up there, and they read compare and contrast titration curves of strong acids and strong bases, and calculate the pH and concentrations of relevant species at differing areas along the titration curve. So a titration, if we remember from last semester, is when we add an acid and a base together in a reaction. And we're going to be studying those in pretty good detail in these sections. I drew a graph here just to show what a curve might be keeping track of. So over time, we are going to add a strong base to a solution of a strong acid, and we're going to track the pH over time. So for the example that I'm going to use, let's just go ahead and assume that I have some acid. Let's see, let's draw the classic beaker over here. I'll put it up here. Let's say we have HCl in here, and we have a burette. And let's use KOH, potassium hydroxide. And we're going to be adding this to this and tracking what the pH is. So let's define the molarity of our HCl and how much we have, and then talk about the pH of our situation. So let's see, I'm going to move this over here a little bit for now. And situation one, we have 25 milliliters of our HCl in the beaker over there, and its molarity is 0.255 molar. So we're going to ask the question, what is the pH at each one of these situations? So for now, we just have no KOH added. So what should be our starting pH before we titrate anything? Well, remember for strong acids, the pH is just going to be the negative log of the molarity, that value. So it's going to be the negative log of 0.255, which is 0.593. So very low or below 1 pH. It's a fairly concentrated solution of HCl. So that's the pH before we do anything in this situation. Trying to make a little more room here. Okay, step two. Let's actually add some KOH. So we're going to add, let's see here, how about just 4 milliliters of 0.150 molar KOH. So we're going to be reacting some of the strong acid with the strong base. All of the strong base will react with the strong acid if possible. So remind ourselves what this looks like in terms of an equation. We have KOH plus HCl to give H2O plus, in this case, KCl. And remember, this is a neutralization reaction, so we are producing solution of water and KCl. However, we're only adding a little bit of KOH to begin with, so our pH after this reaction will depend on what's left over. So let's think about what's actually left over here. And we had, before any reaction occurs, reaction. Let's think about how many moles of stuff that we have, or millimoles. So because these are going to react in a 1-to-1 ratio. So let's do a little bit of calculation down here. As KOH, we're adding 0.150 molars. Actually, you know what? I'm going to start with milliliters times its molarity, and that's going to give me millimoles. It's milliliters times molar. So it's 6 point, whoops, that's going to be 0.6. That's what I'm looking for. So before the reaction occurs, I'm going to say 0.6 millimoles. How much HCl do I have? Well, that comes from the starting conditions. That would be 25 milliliters times HCl's molarity, which was 0.255 0.55. So we've got 6.375 millimoles. So clearly I'm not going to be neutralizing all of the acid here. I'm only adding 0.6 millimoles, and it's going to react in a 1-to-1 ratio with HCl because of my balanced equation. So HCl, I've got 6.375. Water, we don't really care about. KCl, we don't really care about here. Well, we care about them, we just don't have any there. So what happens after the reaction? Well, I actually have to do a reaction here. Actually, I'm going to write this out. What actually occurs? Well, all of this is going to go away, minus 0.6. 0.6 millimoles will react with the millimoles of HCl that we started with. But remember, we're adding something to the other side. We are adding, neither of which is going to contribute to the pH though. So in this case, the pH really just depends on what we have left over. I'm going to go ahead and grab, I'll leave you guys there. Move this up a little bit. And actually just put it off to the side. Okay, so before reaction, reaction, after what we have left over. We have no more KOH, and we are going to have 5.775 millimoles of H plus. And then, some more water, and we created some KCl, which does not have an effect on the pH. So pH is determined by how much HCl we have left over. We have no more KOH. So pH, remember, is the negative log of the moles per liter of H plus. So we have to convert our millimoles back to moles per liter. So what is our new molarity? Well, we have 5.775 millimoles of H plus from the HCl divided by what's our total solution now? Well, we had 25 milliliters, but we just added 4 milliliters of our KOH. So we have a new molarity, and it's about 2, 0.199 molar H plus. So the pH after this little step of our titration equals negative log. So yeah, of course, we have less than we had before. We started with 0.255 molar, and now we have 0.199 molar. So it'll be negative log of that. And that is 0.701. So that's we have 2 points on our graph here. Let's use blue, zoom in. Before any KOH was added, so 0, 0, we were at way down here, like 0.56, a little less than 1. Now that we added a little bit of KOH, we are up to, what was it? 0.7, so not much. We are basically right about maybe here on our curve. And we'll see as we add little bits of KOH along the way, this will slowly raise up as we neutralize a little bit of the acid. But we're always going to have a bunch of excess acid, so the pH is still going to be very low. So that's the first part of what a pH curve for this titration would look like. Now we'll zoom back out and think about situation number 3 here. Grab my pen, we'll go back to white. Just gonna pause this. Okay, so now let's think about third case. pH at the equivalence point. Make sure I spell that right. The equivalence point means I'm going to add enough moles of base to react with all the moles of H plus. So that means add however much it takes, 6.375 millimoles of KOH. So what happens? Well, if I add that much KOH, I'm going to react with all of my acid. So what's left over? I'm just left over with a solution of potassium chloride and water, which is neutral. Potassium chloride is not going to affect the pH. So equivalence point means H plus concentration is equal to the OH minus concentration, and the pH is going to be 7. So if we go back to our pH curve, this is a big jump in the pH. Notice as I go along here on my pH curve, and I'm adding a little bit of KOH, I'm increasing the pH a little bit as I neutralize acid, but look at this big jump. Now we've jumped all the way up to there. So there's always this big jump in these pH curves when we hit the equivalence point. pH equals 7. Just jot that down. That's our equivalence point now. That's at some amount of volume of KOH added. So that's an easy calculation. You see that problem. For strong acid, strong base, that's what we mean by equivalence point. Okay, let's think about a situation where we're adding enough KOH and we're going to go past the equivalence point. Let's see what the pH looks like. So case 4, calculate pH after, let's say, 50 milliliters of KOH is added. So we need to figure out how much hydroxide is left over and how much acid is left over. So if we think back to our reaction, again, I don't really care about these products because they don't affect the pH. So I'm really only curious of how much strong acid or strong base is left over to get my pH. So before any reaction occurs, let's think about what we had. We had 6 point, let's double check, 37 or 3375. I might have wrote that down wrong. Should be 6.375, I believe. Again, these are millimoles. And now how much KOH am I adding? Well, let's do that calculation. 50 milliliters times its molarity, which was 0.15 moles per liter. Molarity times milliliters will give me millimoles again. So this is 7.5 millimoles. So this time we actually have more KOH than HCl. So reaction is going to occur. Now that we have excess KOH, all of this is going to react. And 1-to-1 ratio will react here. And after, we've got no more HCl. So now our pH is going to be determined by how much OH minus we have. So we have 1.1625 millimoles of KOH. So again, pH, we need molarity of our OH minus. So to do that, well, we can get POH and to get pH. So let's get OH minus concentration. Molarity means all of the millimoles divided by all the milliliters. So we have 1.1625. Total solution volume now. So remember the original 25 milliliters of HCl, and we added 50 milliliters of KOH. So that'll be our new molarity, and that is going to be 0.0155 molar. So pH, let's get the pOH, negative log of that, and that equals pH then is 14 minus the pOH, and we are at 12.176. Look at that big jump. So if we go back to our pH curve, so we're past the equivalence point now. Now we've added so much KOH that we're into the basic side of things. And now we're up here. What is it? Oh, sorry, it was 12.176. So we're now up to this point here. So if I start connecting my curve, let's use red to do this. And as we continue adding past that point, so we'll have excess KOH every time, and we'll just keep increasing the pH. So that would be our next points. We'll just keep adding, and that's basically what a strong acid, strong base titration curve looks like if you're starting with acid in your beaker. They have this distinct look. They have this big jump in the middle and these shallow curves on the left and the right. And this is a very typical set of problems that you might see. Calculating the pH at specific points, showing the starting point where you just have HCl, then you add some base to it, you calculate how much HCl is left over. The equivalence point, that's where they equal each other, we get 7. And then we have excess KOH or excess base to produce a basic solution at the end. And this problem, if you're curious, was from section 17.3 in the online book. This was example, get back to white. (17.9). So what you should do next is go into the book, go through that example if you'd like, but you should be doing practice problem 17.9 and go through that one on your own, and they have a answer key for there as well. So I'm going to zoom back out, and this is labeled strong acid strong base titration problem, implying that the strong acid was in the beaker and we're adding a little bits of KOH or strong base to it. Okay, to wrap up this section, 17.3, let's zoom out over here and think about what if we had the opposite, a strong base, strong acid. Oops, ran out of room. Titration. As in, instead of this setup, we have, let's say, NaOH or something. And then on our burette, we have HCl. So if we started with, for example, 25 milliliters of 0.1 molar NaOH, what would the starting pH be? Same type of problem. The starting pH is just determined by the pOH is the negative log of the molarity of the NaOH, and you get the pH from there. So what would the actual curve look like? Well, if I can find my ruler, let's try to draw ourselves another graph here. Wish I could draw nice straight lines like this in real life. All right, that should suffice. So now if we have volume of acid added and the pH over here, so our starting pH would be way up here. Let's see, this is 14, 12, 10, 8, 6, 4, 2, etc. So now in this case, we would simply be starting up here at our starting point. And as we add acid, we're neutralizing a little bit of this at a time. And then once we hit the equivalence point, remember that's going to go way down to 7. That's where, again, we added enough acid to completely neutralize the NaOH. And then after that, we'll have an acidic solution. This is where we have excess HCl. This is excess NaOH. And this is where H plus equals right there. So same type of curve, just flipped in that direction. So that's pretty much section 17.3. Make sure you go through all the practice problems in that chapter to understand how to do these pH calculations.